Step 1. Now, let us assume the mean, and denote it by A to reduce calculation work. Let x1, x2, x3, x4, x5 are the given observations. The center value of the above given observation is x3, so A equals x3. Step 2. Calculate the difference between A and each of the xi, which is the deviation, di. di equals xi minus A. di equals xi minus x3. Step 3. As for all the class intervals, the difference is same. The size of the class is defined by the value h. So let ui equals xi minus A is divided by h. Here, A is assumed mean, and h is class size, where both are non-zero numbers, that is, A is not equal to 0, and h is not equal to 0. Step 4. To find the product of ui with the corresponding fi, and take the sum of all fi ui. U bar equals sigma fi ui by sigma fi. This is equal to sigma fi into xi minus A by h by sigma fi, since ui equals xi minus A by h. This is equal to 1 by h into sigma fi xi minus A sigma fi is divided by sigma fi. This is equal to 1 by h into sigma fi xi by sigma fi minus A into sigma fi by sigma fi. This implies that u bar equals 1 by h into x bar minus A, since x bar equals sigma fi xi by sigma fi. H into u bar equals x bar minus A. Step 5. Finally, calculate the mean, using standard deviation using the formula. X bar equals a plus h into u bar. Therefore, x bar equals a plus h into sigma fi ui by sigma fi. Here, x bar is the mean, in step deviation method. Example 1. Find the mean of the following data. Solution. From the given table, each class interval is having same class size, so we can use either assumed mean method or step deviation method. Before we apply any of the above two methods, first calculate the class mark xi, which is given by the formula. Class mark xi equals lower class limit plus upper class limit is divided by 2. So, from the given table, we observe the first class interval is 10 to 25, for which the class interval is calculated as follows. Class mark equals 10 plus 25 is divided by 2. This is equal to 35 by 2. This is equal to 17.5. Similarly, we can obtain the class mark for the other class intervals by using the class mark formula. But you can also follow this shortcut method to calculate the class interval when the class size is same for all the class intervals. Recall that class size for any class interval is obtained by subtracting the lower class limit from its upper class limit. Here, from the above table, we observe that the class size is same, that is, 15. So, the next class mark is obtained by adding 15 to the previous class mark, that is, 17.5. Therefore, we obtain the value as 32.5 for the class interval 25 to 40. Similarly, the other values are obtained by adding 15 to the previously obtained class marks, that is, we obtain the value as 47.5 for the class interval 40 to 55, since 32.5 plus 15 equals 47.5. We obtain the value as 62.5 for the class interval 55 to 70, since 47.5 plus 15 equals 62.5. We obtain the value as 77.5 for the class interval 70 to 85, since 62.5 plus 15 equals 77.5. We obtain the value as 92.5 for the class interval 85 to 100, since 77.5 plus 15 equals 92.5. Consider the given class intervals, which are 10 to 25, 25 to 40, 40 to 55, 55 to 70, 70 to 85, 85 to 100. Here, each class interval difference is 15. the class size, h, equals 15. So, now let sigma find ui by using the formula, ui equals xi minus a by h. Here, a is assumed mean, and h is the class size. Now, let us find the assumed mean a, for the observations. 17.5, 32.5, 47.5, 62.5, 77.5, 92.5. The center value of the above given observation is considered to be 2, as the list is consisting of even observations. So here, the assumed mean is taken as the two values, that is, a equals 47.5, a equals 62.5. Now, let us choose a equals 47.5. After calculating the class mark, the table consists of values as shown. Now let us calculate the deviation di equals xi minus a and also ui equals xi minus a by h equals di by h. Here, the class size h equals 15. Consider class interval 10 to 25. Xi equals 17.5, a equals 47.5. Then, di equals 17.5 minus 47.5. This is equal to minus 30. Then, ui equals minus 30 by 15, since ui equals di by h. This is equal to minus 2. Similarly, we calculate the values of di and ui for the other class intervals. Now, consider class interval 25 to 40. Xi equals 32.5, a equals 47.5. Then di equals 32.5 minus 47.5. This is equal to minus 15. Then ui equals minus 15 by 15. This is equal to minus 1. Consider class interval 40 to 55. Xi equals 47.5, a equals 47.5. Then di equals 47.5 minus 47.5. This is equal to 0. Then ui equals 0 by 15. This is equal to 0. Consider class interval 55 to 70. Xi equals 62.5, a equals 47.5. Then di equals 62.5 to 47.5. This is equal to 15. Then ui equals 15 by 15. This is equal to 1. Consider class interval 70 to 85. Xi equals 77.5, a equals 47.5. Then di equals 77.5 minus 47.5. This is equal to 30. Then ui equals 30 by 15. This is equal to 2. Consider class interval 85 to 100. Xi equals 92.5, a equals 47.5. Then di equals 92.5 minus 47.5. This is equal to 45. Then ui equals 45 by 15. This is equal to 3.